Algebra 1 students, welcome to your 5.7 notes. We're looking at the first half of the section today. We're going to take a look at scatter plots and trend lines. A very interesting topic with lots of real life applications. Very cool thing to investigate a little bit. And again, something that I think might interest you. I really hope so. All right, so a scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. And since we're talking about real life, a lot of situations will stay in the first quadrant since we don't necessarily have things like, I don't know, negative puppies. That's not pretty. We don't have those too often. So what we do have are correlations that look like this. The first one you can see as we move to the right, the graph moves upward. So you can kind of visualize that graph moving up. That we call a positive correlation. As one value increases, the other does as well. Now sometimes we have a negative correlation, and so as we move forward on the x-axis, our y values are decreasing, so we're getting smaller and smaller. And there are times when there's data that's not connected, so we'd say no correlation. Like for instance, if I were to compare the shoe size of students compared to their birthdays, there's really not much to connect those two things. All right, so when there is a correlation between two pieces of data, it's appropriate to create a line of best fit. Now, when we say there's a correlation, that could be positive or negative. Now, the great thing about it, and the real value, is that it allows us to predict future events, which we call extrapolation, or to predict, events within the data. So maybe we don't have an exact figure, but we want to predict what someone might do or some result. We can, and that's called interpolation, where it's inside the known data. And again, extrapolation is where you go outside. Now, I said future. It could be something in the past as well. We'll see both scenarios. All right, so we need to make a scatter plot. And in this case, we're comparing altitude to temperature. So this is the altitude of an airplane and the temperature. I'm going to start by labeling my graph over here. I'm going to say that this is altitude right here, and this we will measure in, of course, meters. And then over here we have the temp, and the temperature is measured in degrees Fahrenheit. All right. We have to figure out how we want to label this, and when I'm looking at altitude, I'm seeing it goes as high as 5,000. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So it works out kind of well for each tick mark to represent 500. I'm only going to label every 2 tick marks, primarily space issues. Go ahead and label. So we're up to 4,000 meters, and then out here at the end, we would be at 5,000 meters. Okay, now temperature, the highest value we see here is 61.3. Again, I have 10 spaces here. I think it would be appropriate to count by tens. And again, I'm just going to label every other tick mark. Now, I know we won't use the full graph here. So if you wanted to do something besides counting by tens, that's fine. I just don't like to get too complex with something like that. All right, so start labeling your points. The first one we see here, altitude 0, temperature 59. So I'm going to go 0 and 59, getting really close to 60. We're just approximating. 500, we really haven't changed. At 1,000, the temperature has gone slightly up, not much, but then we start to see the decrease. At 1,500, it's 55.5. And jumping ahead, our last point is at 5,000 meters, the temperature just barely above 0 is 0.6. Okay, so let's do the follow-up questions. What type of relationship does the scatter plot show? Well, when you look at this, it's not exactly linear, but you can see pretty convincingly that this is a shift downward. So we would call this a negative correlation. This is one of those graphs where you could move out of the first quadrant. I should point that out because it's very possible that you could have temperatures that drop below 0 based on the information you're seeing here. You would anticipate that being the case as you move further ahead if you were to extrapolate that data. All right, let's take a look at another one. The axis is already labeled for you. Why don't you pause the video, go ahead and fill out your scatter plot, and then we'll start talking about the follow-up questions. All right, welcome back. You can see my scatter plot, a little rough, but you can kind of see where the points are. One thing that I should mention here probably is how I took the gallons bought and dollars spent and used the number of gallons as the independent variable. I suppose that could be debated if I perhaps should have labeled this the opposite way, but the fact I labeled it in advance means we could all do it the same way. So at least if we're wrong together. All right, so what type of relationship does a scatter plot show? Well, you can take a look at that and you can see the graph is moving upward, so we would call that, of course, a positive correlation. The more gas you purchase, the higher the cost. All right, sketch the line of best fit. All right, so let's do this. What I'm going to do is I have the advantage of being able to grab a line tool. I know you can't do that, but you could maybe use a ruler or some other straight edge and try to get a line. I'm going to have to move mine around that fits the data as closely as possible. Essentially, when I do this, I'm trying to get as many points above the line as I have below the line. I'm trying to get that line to go straight through the middle of all the data as closely as possible. I think I've got a pretty good line of best fit right there. And I would say the question, does it seem to be a good fit, is a little bit open to interpretation, but my answer would be yes, all the data points are close to the line. It gets to be a little tougher when the data points are more spread out. It's a little bit tougher to get accurate information. All right, so D, a little prediction. So predict the cost for 4.5 gallons of gas. So I'm going to do is go over here to 4.5. It's this mark here, and I'm going to go up here and mark this point. Now again, your answer might be slightly different than mine, but based on what I'm seeing here, that looks to be very close to $17. Now this question, is this interpolation or extrapolation? Remember, interpolation means you're predicting within the known data set. So like if I wanted to know what 1.5 gallons would cost, I don't have 1.5 marked, but I could use interpolation to predict what 1.5 would be. For anything either before or after the set of data we have, that is extrapolation. And that's what we're talking about here. That green dot is definitely outside the known information. That doesn't mean it's good or bad. It just means we're using it to predict, to extrapolate future or past results. Okay, one last thing we want to talk about. Sometimes there are situations where you have positive correlations, but not necessarily causation. So we'll take a look at that. Causation is when a change in one quantity causes a change in a second. A correlation does not always imply causation, though. So in other words, two things could change together, but not necessarily have one caused by the other. Here are two examples. This one is causation. The distance between two cities and the time it takes to drive between them. The reason it takes longer to drive from Olathe to Wichita than it does to drive from Olathe to Gardner is because Gardner's closer. So the distance is the cause of the driving time. The second example here is not causation, though. The number of Starbucks and the number of teachers in a city. I think that it would be fair to say that teachers have their fair share of Starbucks. However, they don't open Starbucks based on, well, how many teachers does this city have? They look at the population. They look at the type of people that live there, the number of people that live there. And the number of people that live in a city, the population, has a lot more to do with the number of Starbucks or McDonald's, or you could fill in the blank for your business, than it does actually the number of teachers. The number of teachers also is impacted by population, though, because the larger the town, the more students there are, and therefore the more teachers there would be. So those two things would run together. I would imagine if you looked at the number of Starbucks in cities across the country, the larger cities would have more, and the larger cities also have more teachers. But again, it's not directly causing. One doesn't cause the other. Opening a new Starbucks doesn't create new teachers, and having new teachers come to a city doesn't cause them to open a Starbucks directly. All right, tell in each of the following situations if there's a correlation likely, and if there is a correlation, tell whether that is a causation situation or not, and then we'll do a little explanation. So part A, the number of fish in a tank and the food required to feed them. Okay, so the question is there a correlation? Well, I think it's pretty fair to say yes, because the more fish we have, the more food it would require. And then, does causation exist? That one's also a yes, because more fish equals more food. Fair enough? That's pretty bad handwriting. Try to clean that up just a bit. Okay, so the more fish you have, the more food you're going to have to give them. That's just, basic biology. All right, B, a person's birth month and their salary. Is there likely to be a link between someone's salary and the month of the year they were born? I would have to say absolutely not. Okay, there's no relationship there. If you were to look at a scatter plot that compared those two pieces of information, it would be all over the board. Someone who's born in January is just as likely to have a high-paying job as someone who's born in October, and on the same thing on the low end of the scale. Okay, and the last one we have here, the number of pencils sharpened and the number of Kleenexes used in a classroom. Now, there are different factors that could affect these. For instance, pencil sharpening could depend on, is it a math class where the teacher is crazy and won't let their kids use pen? Yes, that's me. What time of year is it? Could affect Kleenexes. There are times when there are lots of kids with the sniffles, so lots of Kleenexes get used during that time. So but I think it's safe to say, though, in general, the more students you have, the more pencils exist. And the more students you have, the more Kleenexes you're going to have to use. So is there a correlation? Yeah, I think so. Well, I say yes and right no. That makes a lot of sense, Hale. I say yes and right yes, even better. All right. And in this case, it would be a positive correlation. Now, the question, though, is there a causation here? And I would say no to that question. The reason, they both increase or decrease together, so they change together. I'll just write it that way. They change together, but one does not cause the other. Again, large number of students probably means you're using more of each of those things. But like I said, sharpening a pencil doesn't cause people to have to use a Kleenex, most likely. All right, folks, that wraps up our 5-7A notes. We're doing all these scatter plots by hand. As we move ahead to the next part of this section, we're actually going to use some technology to do some of these same things. We can get a little more precision, but the concepts we need to understand from this part of it to be able to really do the next part right. So make sure you come ready to work. Have a spectacular day.